Hello students, today let us see a problem from the topic rings from the chapter algebraic structures. This is the set given to us is Z4 set of integers 0, 1, 2, 3. And we are asked to prove it is a commutative ring with the unity with respect to the two operations. One is addition modulo 4 and multiplication modulo 4. First of all, let us see what is the addition modulo 4 and multiplication modulo 4. For addition modulo 4, add the two integers. If it is less than 4, if the resultant is less than 4, take the value as it is. If the resultant is equal or more than 4, then divide it by 4 and take the remainder. The same thing for multiplication modulo 4 also. Multiply the two integers. If it is less than 4, take the number as it is. If it is equal or more than 4, divide it by 4 and take the remainder. And for proving what is the technique we are going to follow? Z4 is a finite set, so we are going to take Cayley's composition table. And addition and multiplication modulo 4 are well-known operations, so let us we verify the properties using illustrative examples. And for a ring, how to prove? What are the things we have to prove? First of all, with respect to addition modulo 4, we have to verify closure, associative, identity, inverse and commutative. And with respect to the second operation multiplication modulo 4, we have to verify closure and associative properties. And with respect to both the operation, we have to verify the left and right distributive properties. And finally, with respect to the second operation, let us verify the commutative and identity. So first of all, let us take the addition modulo 4 and multiplication modulo 4 Cayley's composition table. For example, if we take 2 plus 1, answer is 3, that is less than 4, let us take it as it is. Whereas 3 plus 2, if we take 3 plus 2 is 5, that is greater than 4, so divide it by 4 and the remainder is 1. Same thing for multiplication modulo 4 also. Multiply, take the remainder if necessary. And if we take the first table, addition modulo 4, look at leave the header row and header column and look at the elements inside the table. All the elements are from Z4, 0, 1, 2, 3. So we verified the closure property from table 1. Associative, addition modulo 4 is always an associative operation. Let us verify it using some illustrative examples. Take 3 elements and verify the associative property. And additive identity. So 0 is the additive identity, we know it. Moreover, the header row is repeated in the same order when it is being added by 0. So 0 is the identity that is being written here. And each row, let us encircle the additive identity. From that we can find out 0 inverse is 0. Look at my hand movement. 0 inverse is 0. 1 inverse is 3. 2 inverse is 2. 3 inverse is 1. So that is what written here. All the elements have inverse. And addition modulo 4 is always commutative. That let us illustrate with one example. So with respect to the first operation, the set is an abelian group. And let us verify the closure and associative with respect to the second operation multiplication modulo 4. For that, let us take the table 2. Leave the header row and the header column. Look at the elements inside the body of the table. All the elements are 0, 1, 2, 3 from set Z4. So closure property is verified. And multiplication in modulo 4 is a well-known associative operation. Let us illustrate with one example. So Z4 is semi-group under the operation multiplication modulo 4. And let us verify the left distributive and the right distributive. Multiplication is always distributive over addition. So let us illustrate with some examples. 3 elements let us take and verify the distributive property, left distributive as well as right distributive. So these two are verified here. And so Z4 is a ring under the two operation addition modulo 4 and multiplication modulo 4. And finally, let us verify the commutative and identity with respect to the second operation. Multiplication modulo 4 is always commutative. Let us illustrate with one example. Identity, if we take the table 2, multiplicative identity is 1, that we know already, and let us verify it using the table. The header row 0, 1, 2, 3 is repeated in the same order when it is being multiplied by 1. So 1 is the identity, that is the unity element. So we can say Z4 is a commutative ring with the identity with the unity with respect to the two operation addition modulo 4 and multiplication modulo 4. With this, the problem is over. Let us see another problem in the next video. Thank you.